Welcome back to a busy ECTRIMS 2012. Exciting progress has been made in the development of therapies that not only protect the nervous system, but also repair it and restore motor function. Let's hear more.
You know, we used to think that MS was all about myelin and demyelination. And then the penny dropped about 20 years ago, and really the information's been accelerating since then. We have had a long history of trying to work out why nerve damage happens. And from that, we've worked out ways in which we can try and protect the nerve fibers. The trial we're working on at the moment is designed really to see if we can protect vision in MS. People with MS can sometimes get optic neuritis. For those people where there's loss of vision or where the nerve fibers are damaged in the eye, there's no protection. So the whole idea of this trial is to actually increase the amount of treatment we can provide. Normal nerve fibers, when they're in places where they're inflamed, their metabolism gets affected, and they can't handle the chemicals that normally they would take care of pretty easily, and they build up and they can damage them. And one of them happens to be sodium or salt, which normal cells absorb, but they handle it pretty well. But in MS, we think that the sodium builds up to toxic levels, and the byproduct of that is that the nerve fibers get damaged. So what phenytoin does is it prevents that from building up. So everything is about protecting those nerve fibers. And if we can do that, then we can really try and crack the whole problem about disability.
My lab works on neuroprotection and repair. We have several projects ongoing in the lab. We have 3 that we are most excited about. We've made mice where they show neuroprotection, but we've worked on the barrier that exists between the circulation and the brain. That barrier is called the blood-brain barrier. And normally in MS patients, the barrier breaks down. We've identified a gene that drives blood-brain barrier breakdown in MS lesions, and if we knock out that gene in mice and then induce models of MS, those mice get many fewer lesions. We have a second set where we have deleted a gene which is, we've realized because of the work that the gene is required for myelin formation. If we can manipulate that gene, we can probably promote myelin formation. And the third set of mice, we have identified a factor which is required for the survival of myelin-forming cells in the face of demyelination. There are no drugs available for neuroprotection and no drugs available for repair. We need to develop those drugs.
The amount of information that we're gathering and the number of trials that we're trying to set up and the initiatives that are going on around the world mean that we're going to build up to a sort of level where there's bound to be a breakthrough.
And when we are able to do that, we'll be able to protect hundreds of thousands of people and improve their quality of life.
Tomorrow we'll hear breaking news about a potential emerging IV strategy for people with progressive MS. We'll also hear study results about some complementary strategies for people with MS, such as CCSVI and UV radiation. We'll see you then.